And let's take a look at Monday's daily math. The first question asks you the value of the 8 in the number 4,289,302. So here is my 8. I can see that is in the 10,000ths place value, so the value of the 8 is 80,000. The next one wants to know the value of the underlined digit in 7,390,276. I can see that the 7 is underlined. It's in the tens place value, so its value is 70. Next, we're rounding the number 4,278,649 to the nearest hundred. So I'm going to look at my hundreds place value. I have 6 hundreds, and I'm going to go ahead and underline everything bigger than my hundreds place value because I know I'm going to keep them the same when I round. I'll look to my next smallest place value, which is a 4. That's below the midpoint. So everything stays 4,278,000. The 4 tells the 6 to stay the same. And I have 0 tens and 0 ones. 4,278,600. Next, I'm finding the sum. So I'm adding 14,389 plus 4,309. I'm making sure to line up my place values. If I start in my ones, 9 plus 9 is 18. Write down the 8, carry the 1. 1 plus 8 is 9. 3 plus 3 is 6. Put my comma. 4 plus 4 is 8. And 1 plus nothing is 1. So my answer is 18,698. Next, I'm looking for the quotient. So I'm going to divide 4,298 divided by 4. This is my total number of things that I have, and I'm dividing them into 4 equal groups. I'm going to make my 4 groups. So I have 4,298. I want to see if I can get rid of my largest amount first. So I see that I have 4,000s. I can give 1,000 to each group. That gets rid of all 4,000s. Then I have 200. So I can't give 100 to each group. But if I do some mental math, I know that I can give 50. 50, that makes 100. Another 50 is 150. And then another 50 makes 200. So I've gotten rid of all 200 of those. So now I just have 98 left. I'm going to take care of my 90. Well, I know that I can't put that equally into each group, but I could give each group 20 more. 20, 40, 60, 80. That leaves 10 left over. Now I have 8 ones, so I have 18 left to put into 4 groups. I know 4 times 4 is 16. That's as close as I can get to 18 without going over. 4, 8, 12, 16. So in each group, if I add what I have in each group, I have 1,000 plus 50 plus 20 plus 4. If I add that together, I have 1,074 in each group. And remember, when I put 4 into each group, that made 16. So I have 2 left over that I could not put equally into the groups, so my remainder is 2. 1,074, remainder 2. At the bicycle shop, there are 23 bicycles and 18 tricycles. Each bicycle has 2 wheels and each tricycle has 3 wheels. How many wheels are there in the bicycle shop? So I need to know how many bicycle wheels there are. I'm going to do 23 times 2. I know that 20 times 2 is 40. And 3 times 2 is 6. So if I add those together, that gets me 46. There's 46 bicycle wheels. Then there's 18 tricycles. Tricycles have 3 wheels. So if I do 10 times 3, that gets me 30. 8 times 3 gets me 18. Sorry, 8 times 3 does not get me 18. Let me back up there. I was looking ahead at something else. So 1 times 3 gets me, or 10 times 3 gets me 30. 8 times 3 gets me 24. Now if I add those together, 30 plus 24 is 54. If I add 54 tricycle wheels plus 46 bicycle wheels, I get a total of 100 wheels. Sorry about the mistake there. I'm going to skip on to the next. Okay, list the first 5 multiples of 7. So remember, when we list multiples, we're skip counting. I'm thinking 7 multiplied by a number. So 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. And 7 times 5 is 35. Now I'm going to put all the factors of 7. And it says in increasing order. Increasing just means as they get bigger. So 1 times 7, we can always start with 1 times itself. That will always be a factor. 7's not even, so I can't do 2 times anything to equal 7. I can't do 3 times anything to equal 7. It'd be 3, 6, 9, so that 3 is not a factor of 7. 4 times 1 is 4, 4 times 2 is 8, so that's not a factor. 4 times, I can't do 5. 5 and then 10, so 5 is not a factor. Of course, 6 would not be a factor, and we already have 7. So the only factors of 7 are 1 and 7. Since there are no other factors besides 1 in itself, 7 is a prime number. Last question for Monday. Analyze the pattern below. What will the 15th shape be? So the first shape is a triangle, second is a circle, third is a square. Remember this said 15th? I noticed that 3 is a factor of 15. So that tells me that since there's 3 shapes that repeat, that's going to tell me that each multiple of 3, 6, 9, 12, 15, and so on, it's going to end the pattern before it starts back over. So 15 will be a square. Okay, let's take a look at Tuesday's daily math. So the first 2 questions ask you to compare the numbers. The first one has 874,023 and 874,233. So if I look, the largest place value is the same, the 10,000s are the same, the thousands are the same, so I'll move on to the hundreds. Here I have 0 hundreds and 2 hundreds. I know 0 is less than 2, so I need to put the less than symbol. Next, we're comparing 5,493,820 and 5,492,483. My millions place value is the same. 100,000s are the same. 10,000s are the same. Then I have 3,000s and 2,000s. I know 3 is more than 2, so I need the greater than symbol. Now I'm writing the number 2,845,928 in expanded form. So to put a number in expanded form, I need to write the value of each of the numbers. So I have the value of the 2 is 2 million. The value of the 8 is 800,000. Plus the value of the 4, 40,000. Plus the value of the 5, 5,000. Plus the value of the 9, 900, plus the value of the 2, 20, plus the value of the 8, which is in the ones place, so it's only 8. The first choice is correct. Okay, next, we're finding the difference. So I need to subtract 73,529 minus 9,199. So once again, I'm very careful to line up my place values. 9 minus 9 is 0. Next, I have 2 minus 9. That would get me a negative number, so I'm going to come over to my hundreds. Take one of those away. So now I have 4 hundreds, and I'm going to give those to my tens place. It takes 10 tens to equal that 100. So 10 plus the 2 I already have makes 12. 12 minus 9 is 3. 4 minus 1 is 3. Put my comma. If I come over to my thousands place, 3 minus 9 makes a negative number, so I'm going to borrow one of my 10,000s. That leaves me with 6. I'm going to add 10 to the 3, which makes 13. 13 minus 9 is 4, and 6 minus nothing is 6. So the difference is 64,330. Next, I'm finding the product of 3,928 times 6. So I'm going to multiply the value 3,000 times 6, 900 times 6, 20 times 6, and 8 times 6. I know that 3 times 6 is 18. And I have 3 zeros at the end of that. 3 times 6 gets me 18. And I add my 3 zeros. 900 times 6. 9 times 6 is 54. And I have 2 zeros. So I'm going to add my 2 zeros at the end. Now I have 20 times 6. 2 times 6 is 12. I have 1 zero to add. And I have 8 times 6. Be 48. Now I need to add all of those partial products together, all those parts. 0 plus 0 plus 0 plus 8 is 8. 0 plus 0 plus 2 plus 4 is 6. 0 plus 4 plus 1 is 5. Go to my thousands place. 5 plus 8 is 13. I'm going to carry the 1. And 1 plus 1 is 2.
Miss Porter, could you come to the office, please?
And the answer is 23,568. Next, I'm looking for the sum. I've got 43,498 plus 672,602. Once again, I'm lining those place values up carefully. 8 plus 2 is 10. So there's 0. I'm going to carry the 1. 1 plus 9 plus 0 is 10. Carry the 1 again. I know 4 and 6 make 10. If I add one more, that's 11. 3 and 2 make 5. Plus 1 is 6. 4 plus 7 is 11. I'm going to write down my 1. Regroup the 1. 1 plus 6 is 7. So my answer is 716,100. Next, Carlos had 48 brownies. He ate 3 brownies and then gave 2 brownies to each of his 15 friends. How many brownies does Carlos have left over? So we know he started with 48. If he ate 3 brownies, he's getting rid of those. So I'm going to subtract that. 48 minus 3, that leaves him with 45 brownies. And then gave 2 brownies to each of his 15 friends. So if he gives 2 each to his 15 friends, I know that if he gave 2 to 15 friends, that would be 30. If he gave another 2 to each of those 15 friends, that would be 60, but we don't have that many brownies. We only have 45 brownies. So that means he had 45. He gave 30 of them away. If I subtract that, he has 15 brownies left. So he could either keep those brownies, or he could go ahead and give each one of his friends 1 more brownie, and then he wouldn't have any left over. But to answer the question, how many brownies does Carlos have left over? He would have 15 brownies left. Next, we're listing the first 5 multiples of 25. So we're skip counting by 25. Thinking about quarters here. 25, 2 quarters would make 50 cents. 3 quarters would make 75 cents. 4 quarters makes $1 or 100 cents. And 5 quarters would make 125 cents or $1.25. So that kind of thinking about quarters helps me to think about multiples. Remember, you're always wanting to look for those strategies that are going to make things easier for you. So the factors of the multiples of 25 are 25, 50, 75, 100, and 125. That would be the first 5 multiples. Now we're going to look for the factors of 25. I know I'm going to start with 1 times 25. 25 is not even, so 2 will not be a factor. I'm going to check to see if 3 is a factor. 3, 6, 9, 12, 15, 18, 21, 24, 27. So 3 is not a factor. I'll check 4, 8, 12, 16, 20, 24, 28. 4 is not a factor. I did not get to 25. No, I'm going to check 5. 5, 10, 15, 20, 25. 5 times 5 equals 25. And since it's 5 times 5, I only have to list that 5 one time. So the factors of 25 are 1, 5, and 25. Is 25 prime or composite? Well, it has more factors than 1 and itself. 5 is also a factor, so 25 is composite. All right, next we're going to look at this pattern. The directions tell you, I know it got cut off, but the directions tell you to complete the chart and determine the rule for the pattern. What is the rule? So in this first picture, I have 3 squares in the array. Then in the next one I have 6, then 9, then 12. So looking at that, I can see they've got it nice and organized for us into arrays. I'm going to switch colors here real quick. So the first time I have one column with 3 rows, or I can see that that would represent 1 times 3. Next I have 2 columns with 3 rows. 2 times 3 equals 6. Now I have 3 columns with 3 rows. So 3 times 3 equals 9. Next I have 4 columns of 3 rows. 4 times 3 equals 12. So that shows me that the rule is I'm multiplying by 3 each time. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. Now if I skip down to 10 and did 10 times 3, that would equal 30. So to answer in these little selection boxes you have, if I had 3 rows, there would be 9. If I had 4 rows, there would be 12. If I had 5 rows, there would be 15. And when I have 10 rows, there would be 30. And that got cut off when I took the screenshot of your actual daily math, but you had to drag that over to find the 30 to select. So remember we said what was happening is each time we were multiplying by 3. So the rule for the pattern is n times 3. It doesn't matter what number I substitute for the n, I will always multiply it by 3 to get the other side of the table.